Shalom to you. We'll continue our review on circles. So let's solve problems on tangent and tangent. So here we are given these three circles are tangent and as shown. And so we are given AB is 7, level. So we can see visually what they are in the picture. AC is 11. Okay. And then we are asked to find their radius, the radius of circle A. So, but we don't know the radius of any of them. Let's label them with with a variable. Whatever we don't know, we label with a variable. This is also radius of circle A. Since they have the same measure, already are congruent, I label them with the same letter. So I do the same thing for radius of B and for radius of circle C. And now we can use segment addition postulate to set up equations. A plus B equals 7. So A plus B equals 7. And also, we know that B plus C equals 10. And A plus C equals 11. So these are three true equations. Now we can take them one at a time in system of equation because there are three, more than one. Take them two at a time and work with using substitution or elimination to solve for these variables. So now here I see that C, they have the same coefficient, so I can use elimination. So I'm going to take this equation, A plus C equals 11 and B plus C equals 10, and subtract them. So if I subtract them, because that subtraction is the only thing that can eliminate C. C minus C is 0. Therefore, we have A minus B equals 11 minus 10 is 1. So that's a new equation here. So we have worked with those two equations. Now we take the ones we didn't work with. Okay, this one is, we use that one. So we're going to take this one. Also, with this is A plus B equals 7. And because here I see that BB, the same coefficient. So again, I can, since they are coefficient, they are different. So one is negative, one is positive one. So we add them because addition will make it 0. Okay, negative 1b plus positive 1b is 0. So here I have A plus A is 2A equals 1 plus 7 is 8. And so solve for A. So A is going to be 4. Divide both sides by 2. So now we have one of them. So once we have one of them, we go back here. If A is 4, so what is that's going to be? So I'm going to just erase one of that. You have A here. You can erase one of the B2 and one of the C. Okay, so that way we can have space to write there what they are. So we found that A is 4. If A is 4, of course, since we know this length, I think I erased it accidentally. So this is 7. So we can use that to find B because this side is B, right? So that would be 7 minus 4. That will give us 3. So B is 3. So B is going to be 3. And then we do the same thing here. A here is 4, and this is C. So 11 minus 4 is going to be 7. So C is 7. And now we have found all the radii. Guess again, because again, and then they ask, so A is 4, B is 3, C is 7. So they ask 2, what's the largest? So the largest is going to be C, and why? Because C has the longest radius. The one with the longest radius should be the largest circle. You see, when we look at this, we will think that A is the largest circle. So that's why we don't go by the way it looks. We don't assume. We have to have an evidence to prove what we said. So we see we have proved that C, even though it looks like the smallest, it is actually the largest circle here because of, maybe it has been shrunk, but it's the largest because of the radius is longest. Okay, very good problem. All right. So this one says two tangent circles have radii. Okay, they are tangent. So one of them is large. It has a radius of 8. The other one is smaller, but they are tangent. That's right. So this kind of have a radius of 2. It looks like a little bigger, big to compare with the proportion. But anyway, we are looking for the external tangent. Has to be outside here, and because it's tangent to a radius, it has to be perpendicular to the radius. And then what do? We are looking for the length of this external tangent. Let's label it L. And so we can close this up to become a polygon. So we can close the here, because what we know, this is the radius of this also is going to be 8. Here is going to be 2 also. So we have a total of that side. It's going to be it's going to be 10. So that length is going to be 10. Okay, what does that look like? It looks like a parallelogram. Looks like a trapezoid, because the two radii will be parallel to each other. Okay, and it's proportional too. So when we have this type of problem, external tangent, internal tangent, the key is try to create a rectangle. Try to create a rectangle. So we can start from this corner and draw a rectangle that will come down here. So this line is going to be parallel to this line we just drew, making it a rectangle, and so that would be 4 right triangle. And of course, this side of the rectangle, which is the radius of this circle, small circle, is going to be the same as here. So we're going to have 2 on that side. So if we have 2 here, what is left? What will be the side of this triangle? And of course, this is going to be perpendicular also. So it's going to be 90-degree angle here. So it's going to be 6, because they have to make up 8 for this radius. And now we have that triangle. I'm going to just make it so we can see that. Okay, so we have the right angle there. And with that, because two opposite sides of a rectangle are congruent, opposite sides of a rectangle are congruent. So if we can find this length, or in red, then we can find the length we are looking for. So since they are the same measure, let's just label them all LL, okay? Because they are the same measure, label that L. And we already know this length is 10. We know this length is 6. So it's a right triangle. We can use Pythagorean theorem to find it. The side opposite right angle is 10. So we're going to be 10 squared. And if we remember right away, since the hypotenuse is 10, one of the, it looks like smaller leg is 6. So by Pythagorean triple, we can tell that this L is going to be 8 actually. But let's just work that out. So it's going to be 8 squared plus, oh, I'm sorry. Sorry, gonna be 6. So it's going to be 6 squared plus L squared. So this is 100 equals 36 plus L squared. So subtract 36 from both sides. Okay, so it's going to be 64 equals L squared, and the square root of 64 is going to be 8. All right, that's it. Again, but if we remember the Pythagorean triple, we can tell right away that that would have been 8. That's that. So whenever you have external tangent, internal tangent, find a way to create a rectangle and then work around that. All right. All right, in this problem, we are told that we are not told that these two circles are tangent, so we cannot assume it. So we'll just draw them as if they are not tangent. So just two circles, and we only told that the distance between their centers. So if we connect their centers, we're going to get 16. And then we're looking for the internal tangent. So internal tangent will be able to cross, if we draw it from one side to the other, it's going to cross that line that connects their centers. That's one of the properties. Again, internal tangent has to cross this line that connects the center of the circle. And then we can draw the radius. The radius of the big circle is 8, and the radius will be perpendicular to the tangent. And then we can draw the other radius here also. It's going to be 2. It's going to be 2. Okay, so what we are looking for this line, the tangent, let's label it T, that internal tangent. Okay, so what can we do? Again, whenever you have internal or external tangent, find a way to draw a rectangle. And so, of course, the tangent will be perpendicular to the radius here. Since this is the line we are trying to find, we can draw a line parallel to that line. So we can draw a line here, a rectangle there. Then this is a rectangle. Okay, I'll just draw that. And because this is 8, this side will be 8 also. And this is T, that will be T, because they are parallel and opposite sides of. Okay, and now we have like a rectangle here. I'm going to trace it in a different color. Rectangle here, which is T, and then we have this whole side, which is going to be 10. Because 8 plus 2, the 8 here plus 2 is going to be 10. And then we know this side, which is the 16, that connects the two centers. Okay, again, we don't forget that those are the center. So, and of course, because this triangle is a rectangle, not triangle, sorry, we know it's perpendicular there. So, therefore, we can use Pythagorean theorem again to set this up. So the hypotenuse is 16. So 16 squared is equal to T squared plus 10 squared. So 16 squared is going to be 256 equals T squared plus 100. So if we subtract 100 from both sides, okay, we're going to get 156 equals T squared. And now we can take the square root of 156 to find T. So we're going to find the perfect square that goes into 156. So that will be 4 square root of 4 times square root of 39. So square root of 4 is 2. 2 square root of 39 equals T, and that would be the exact answer.